I'm looking at scikit-learn's _estimate_bandwidth function. It's a tool we use to find the best bandwidth setting for density-based clustering methods like mean shift. We have a dataset, X, which is a NumPy array. It has 100 data points, each with 2 features. Think of it like a spreadsheet with 100 rows and 2 columns. Each row represents a data point, and each column represents a feature of that data point. This is where we use the _estimate_bandwidth function. I'm giving it the dataset X and setting the parameters, quantile to 0.2, and n_samples to a certain number, which we need to interpret. The function will output a single number, the bandwidth. This number influences how the density-based clustering algorithm groups data points together. A larger bandwidth means considering wider neighborhoods, and a smaller bandwidth will lead to tighter, more localized clusters. The quantile parameter, set to 0.2, or 20%, means I want the function to pick a bandwidth so that 20% of the distances between all pairs of data points are smaller than that bandwidth. So, if there are a large number of data points and it is set to 0.2, it selects a bandwidth so that 20% of pairwise distances lie below this value. This statement is wrong. The bandwidth isn't directly the radius in mean shift. Instead, it helps define a kernel, often a Gaussian kernel, a bell curve-like distribution, around each data point. This kernel determines how strongly that point influences its neighbors. The bandwidth determines the spread or width of this kernel. The n_samples parameter sets a limit on how many data points the _estimate_bandwidth function uses. If the dataset has fewer data points than the value provided to n_samples all the points are used. However, if there are more data points than the value provided to n_samples only a subset of the data points is used for computational efficiency. This is important for large datasets, to speed up the calculation. This statement is false. The bandwidth is a distance. Its value depends on the spread of the data points in the dataset, and it's not restricted to be between 0 and 1. I'm using scikit-learn's estimatebandwidth function, a tool that helps me find the optimal bandwidth for density-based clustering. Think of the bandwidth as the scale at which I measure density in my data. A larger bandwidth means I look at broader areas when determining density. My data is a NumPy array called X, a table with 100 rows and 2 columns. Each row represents a data point, and the 2 columns represent its features. This statement is wrong. The bandwidth isn't confined to 0 and 1. It depends on the distances between my data points. It can be any positive number. This is correct. I set nsamples to 500. That means I'll use at most 500 data points for my bandwidth calculation. If I have fewer than 500 data points, I use them all. This statement is right. The quantile parameter is set to 0.2 or 20%. I'm telling the function to find a bandwidth so that 20% of the distances between all my data points are smaller than that bandwidth. Incorrect. The bandwidth isn't the radius directly used in the mean shift algorithm, although it's crucial. It determines the size of the kernel used to search for density peaks in mean shift. It's a function that is found in the scikit-learn library and it's used for clustering. This is the result of my estimatebandwidth calculation. It tells me a useful scale for measuring the density of my data points. I'm using scikit-learn's _estimate_bandwidth function, a tool that helps me find the best bandwidth setting for density-based clustering algorithms like mean shift. It's like finding the right zoom level on a map. You need the right scale to see the clusters clearly. This line shows how I use the function. X is my dataset. Quantile equals 0.2 tells the function to consider the bandwidth that separates the closest 20% of data points. n_samples equals. Limits the number of data points used for calculation, improving efficiency, especially with very large datasets. This statement is true. The n_samples parameter acts as a cap. If my dataset has fewer than 500 points, the function uses them all. It's like saying, use up to 500 points, but if you have fewer, use them all. This one is also true. Quantile equals 0.2 means I want a bandwidth that's bigger than 20% of the distances between data points. It's like setting a threshold. 20% of my points will be closer than this bandwidth. My dataset, X is a table with 100 rows and 2 columns, representing 100 data points each with 2 features. Think of it like a spreadsheet with 100 entries, each having 2 numbers describing it. The function's output is a single number representing the bandwidth, the ideal distance scale to use for clustering. I'm analyzing the scikit-learn function, estimatebandwidth, which helps determine the optimal bandwidth for density-based clustering algorithms like mean shift. It's a crucial step in these algorithms because the bandwidth directly impacts how we define the density of data points. Think of it like deciding how big a magnifying glass you need to properly identify clusters in a scattering of dots. Our dataset, X is a NumPy array. It contains 100 data points, each described by 2 features, hence the shape, 100, 2. Imagine each data point as a location on a map with 2 coordinates. I'm calling the estimate_bandwidth function with specific parameters. Quantile equals 0.2 and n_samples equals 500 Quantile controls the percentage of pairwise distances considered, and n_samples limits the number of data points used in the calculation. This statement is true. n_samples sets an upper limit. If I have fewer than 500 data points, the function uses all of them. Otherwise, it randomly samples 500. It's a way to speed up the calculation for large datasets. This is also true. The quantile parameter is super important here. It means I'm selecting a bandwidth so that 20% of the distances between all pairs of data points are less than the calculated bandwidth. This statement is false. The bandwidth is a distance measure. It isn't constrained to be between 0 and 1. The range depends entirely on the dataset's scale and distribution. This statement is false. While the bandwidth informs the mean shift algorithm, it isn't directly the radius. Instead, it influences the kernel, often Gaussian, used around each point, affecting cluster identification. I'm using scikit-learn's estimate_bandwidth function. It helps me find the best bandwidth for density-based clustering methods like mean shift. Think of the bandwidth as the scale at which I look for clusters. A larger bandwidth means I consider larger neighborhoods around each data point. My dataset, X, has 100 data points, each described by 2 features. Imagine these are points plotted on a 2D graph. I'm calling the function with my dataset, X quantile equals 0.2 means I want to find a bandwidth such that 20% of the distances between all pairs of data points are smaller than this bandwidth. n_samples controls the number of data points used in the calculation, for efficiency purposes. Yes, that's exactly right. The quantile equals 0.2 setting in estimate_bandwidth directly relates to this idea. 20% of the pairwise distances are less than the bandwidth the function computes. Correct. The n_samples parameter acts like a cap on the number of points used for calculating the bandwidth. If I have fewer than the specified number of points, then I use all of them. The output of estimate_bandwidth is a single number representing the bandwidth. This number determines the scale or reach at which the mean shift algorithm searches for dense clusters in the data. I'm using scikit-learn's estimatebandwidth function. This function helps me find the best bandwidth for density-based clustering. Think of bandwidth as the scale at which I'm looking at the density of my data points. A larger bandwidth means I'm looking at a broader area. My data is in a NumPy array called X. It has 100 data points, each with 2 features, like X and Y coordinates. These are the settings I'm giving the function to control how it works. I'm setting the quantile parameter to 0.2, or 20%. This means I want the bandwidth to be chosen such that 20% of the pairwise distances between all my data points are less than this calculated bandwidth. I'm limiting the number of data points used to calculate the bandwidth to a maximum of 500, even though I have 100 data points in total. If I had more than 500, only 500 would be randomly sampled. This is to make the calculation faster. The function now uses the data and settings to calculate the optimal bandwidth. It does this by calculating the distances between many pairs of points and choosing a bandwidth based on the QUANTILEI specified. The function returns a single number, the estimated bandwidth. This number represents the optimal scale for density estimation in my data. The output is a single number, which is the bandwidth. This is false. The bandwidth is a distance. It depends entirely on the data. It's not stuck between 0 and 1. This is true. The NSAMPLES parameter sets a limit. If I have fewer points than 500, it uses all of them. This is true. The QUANTILE parameter controls the percentage of distances used for bandwidth calculation. A QUANTILE of 0.2 means 20% of the pairwise distances will be below the estimated bandwidth. This is false. The bandwidth doesn't directly become the radius in mean shift. It influences the kernel. It's a key ingredient but not a direct substitution. It's like saying the flour is the cake. I'm using scikit-learn's estimatebandwidth function. This function helps me find the best bandwidth for density-based clustering algorithms like mean shift. Think of the bandwidth as the scope of my search for clusters. My input data is a NumPy array called X. It's a two-dimensional array with 100 data points, each having 2 features. Imagine it as a list of 100 locations on a map. Each point has an X coordinate and a Y coordinate. I'm setting the QUANTILE parameter to 0.2, or 20%. This tells the function to choose a bandwidth such that 20% of the distances between all pairs of data points fall below that bandwidth. I'm also setting the NSAMPLES parameter to 500. This limits the number of data points the function uses to calculate bandwidth to a maximum of 500. If I have fewer than 500 points, it will use all of them. This is a clever way to speed things up when dealing with massive datasets. The function gives me a single number, the estimated bandwidth. It's a measure of distance that helps to define the neighborhood around each data point for clustering.